Okay, so a question like that, I should be able to ask for increasing intervals, decreasing intervals, zeros, x-intercepts, y-intercepts. Ooh, I could even be more creative than that. I can also ask for domain. I can also ask for range. Ooh, I could also ask for, how much more can I ask for? I could ask for local max. I could ask for local min, since we just did that. I could ask for absolute max. I could ask for absolute min. Once you start learning stuff, it's amazing how much it just keeps going on and on and on and on and on. Local max, min, range, and then I could also ask you what type of function is this? I could also ask you what type of function this is. Which might be tricky the way I drew it, since I kind of hand drew it, but I'm thinking I can ask that question. Okay, so answer those. I'll give you a few minutes and then we'll put the answers up. Okay, vast majority of you, I think the pencils have stopped moving. Okay, domain. Domain should be really, really easy for this, right? Left to right, how far left does it go? How far right does it go? So domain is negative infinity to positive infinity, which they won't always be that way, but this one turned out that way. All right, range, how far down does it go? Forever. How far up does it go? So again, negative infinity to positive infinity. So those weren't hard. Okay. Now I threw in this extra question here. Is the function continuous? Can I draw the entire function without lifting my pencil? Yes. If I can draw the entire function without lifting my pencil, then it is continuous. So the answer is yes. Okay. Yes, it is continuous because I can draw the entire thing without lifting my pencil. All right. Now this one might be a stretch. All right. Because I was just randomly drawing a picture here, but I went here kind of curvy, and then I distinctly made a cusp here and went straight this way. So what type of function is it? Say it, Parker. Yeah, read my mind, read my mind. What was the very first thing we talked about today? Piecewise functions. Isn't this piece nice, curve, and smoothing? Could be some type of polynomial curve. And then isn't this piece straight, like a straight line? So it's in pieces. The two pieces happen to be touching each other. This straight, that was supposed to be a straight line, would be a linear portion. This could be represented by some type of polynomial curve. All right, so it's in pieces. It's in two pieces. So I would say this is a piecewise function, regardless of how poorly I did draw it. Okay, so it's a piecewise function. All right, increasing intervals. All right, so increasing, if we color code this a little bit, I'm increasing all here and I'm increasing here. Hopefully increasing was easy for you to grasp. I use curly brackets always, and I use x values. So negative infinity all the way up to my x value of -2, a u, start back at my x value of 3 and goes all the way to infinity. So I use intervals. All right, the only decreasing portion of the function is right in here. All right, again, using x values and always curly brackets, the decreasing portion goes from -2 to the x value of 3. Always curly brackets, always x values. All right, zeros. Zeros are what? Zeros are the place where the function crosses the x-axis. It crosses the x-axis in one spot. So x equals -5. When I ask for a 0, x equals -5. Because a 0 is also a solution to the equation, and it's also located in the same spot as the x-intercepts. However, when I ask you for an x-intercept, you write those as ordered pairs most of the time, so -5, 0, when we do things by hand. Okay, and that's the only place that the only x-intercept. All right, y-intercept, the point at which it crosses the y-axis. the ordered pair 0, 3. All right, so local max. What's the local max? -2, 5. Local max is -2, 5. All right, and just writing them as ordered pairs, knowing that I could have said, where is the local max located at? It's located at x equals -2. I could have said, what is the value of the local max? That would be 5. All right, local min is the ordered pair 3, 0. It's on the inside. It's the lowest point in there, so 3, 1. Now, absolute max, how high does the graph go? Positive infinity. So it's not an ordered pair. It's more of an idea. Absolute min, what's the absolute farthest point it goes down? Negative infinity. All right, so that is putting together quite a lot of things over the last few days that we have been doing. Domain range, I threw in continuous. We've learned piecewise today, max and mins today. All of these 3, 4 things here, 5 things should have been reviewed. Okay. Now, when doing things in Math Excel, you've got to read the question. You have to read the directions, round to the right spot. I'm seeing a lot of people not rounding to the right number of places. It'll say round out 3 places, you round to 2. Okay, or it'll say enter an integer and you enter an ordered pair. Or it'll say enter an ordered pair and you enter an integer. So you have to pay attention to what it's saying, because I'm going in and looking, and that's the kind of mistakes that I'm seeing on that. Okay, so just make sure you're entering the right stuff. All right, we got about 4 minutes. All right, which I did not leave you a lot of time, but I didn't see you yesterday. I'm not going to see you tomorrow. We need to get a lot of stuff done. Okay. All right, so you got 4